Prepare yourself, as the greatest time capsule humankind has ever seen is about to have its contents revealed after a 50-year wait. In December of 1972, astronauts geologists were able to acquire lunar soil samples, and since then, NASA has kept the collection sealed. So why did they wait for so long? And what do they hope to learn from its revelations? You're certainly about to join the world's greatest astronomers and discover what's inside these samples of the celestial body we call the Moon. The Apollo 17 manned lunar landing mission was the final in a series of missions in the Apollo program, and it was greatly successful. The mission was straightforward, with the scientific objectives to: Number 1. Conduct geological surveying. Number 2. Sample surface materials in the area known as the Taurus-Littrow region. Number 3. Deploy and activate surface material experiments. Number 4. Conduct in-flight experiments. And Number 5. Complete the photographic tasks during lunar orbit and the trans-Earth journey. But before NASA's teams could blast off, adjustments to the Apollo 17 spacecraft were necessary. The main modification was to the Scientific Instrument Module, or SIM, which was needed to conduct 3 new orbital experiments. But it wasn't that simple. Aside from adjusting the SIM, many minor changes were made to the spacecraft because of problems that occurred during the Apollo 16 mission. Among the multiple minor changes, the most tedious and meticulous consisted of redesigning the lower edge of the thermal shields on the aft equipment rack on the lunar module, or LM, to prevent exhaust gases from entering the cavity behind the shields. The LRV, or Lunar Roving Vehicle, was essentially unchanged. However, extensive changes were made to the experiment palette to accommodate experiments unique to Apollo 17. In total, the spacecraft consisted of 3 modules: a lunar module, command module, and a service module called the CSM. After the spacecraft orbited the Moon, the LM and CSM separated. 2 astronauts in the LM landed on the lunar surface, while the CM pilot remained in lunar orbit in the command module. The main astronauts of the Apollo 17 mission consisted of Eugene A. Cernan, the mission commander. Aside from participating in Apollo 7, Apollo 10, as well as Apollo 14, Cernan was the 11th person to actually do the moonwalk. Wait, not that moonwalk. Next, we have Ronald B. Evans, who was the command module pilot. Chosen in the 5th group of astronauts in 1966, Evans later went on to become the backup command module pilot for Apollo 14. And following that, he was the backup command module pilot for the Apollo-Soyuz test project. And last, but certainly not least, we have Harrison H. Schmitt, who was the pilot for the lunar module. He was chosen in the 4th group of astronauts in 1965, acted as the main backup lunar module pilot for Apollo 15, and he became the 12th man on the Moon. Finally, in May 1974, he was named NASA's Assistant Administrator for Energy Programs until he resigned from NASA in 1975. 50 years ago, these brave men risked their lives to gain more knowledge for mankind. When Cernan and Schmitt reached the surface of the Moon, they used 2 14-inch or 35-centimeter tubes to dig in and scoop out the extraterrestrial soil. These tubes, also known as drive tubes, were hammered down, one atop the other, into an area that had experienced a landslide. The bottom half of the tube was sealed on the Moon before the return trip to Earth, since there is only one other sample ever collected under these conditions. NASA explained that this process is quite unique. This sealed tube, which is currently being opened, was stored in an outer vacuum tube and then kept in an atmosphere-controlled environment for half a century. As for the other half of the segment, which is the top half, it was returned to Earth in a normal unsealed drive tube. Then, in 2019, when it was opened, it revealed rocklets, or grains and smaller objects which were deemed as very interesting for lunar geologists. And until now, the collections of their journey to the Moon have been mostly untouched. Once the tubes were filled with rocks and soil, the astronauts, Eugene Cernan and Harrison Jack Schmidt, vacuum-sealed one of the tubes, while the other was put in a normal unsealed container. Both were brought back to Earth. Now, 50 years later, new tools have been developed that will provide much more insight into the celestial body that floats in our sights at night. Scientists at NASA's Johnson Space Center in Houston are preparing to carefully open that first tube, which has remained tightly sealed all these years since that 1972 Apollo 17 mission, which also marked the last time humans set foot on the moon. Well, teams at NASA didn't exactly have to be rocket scientists to know that science advancements in the future decades would mean enhanced technology and techniques available to study the rocks that would yield more results when analyzed. This notion was reinforced by NASA's Planetary Science Division Director, Lori Glaze, who was quoted saying, "The agency knew science and technology would evolve and allow scientists to study the material in new ways to address new questions in the future. Plus, with NASA's Artemis program, which has a mandate to send astronauts to the moon in 2025 or 2026, NASA officials determined the time is ripe to examine the sample from Apollo 17. In 2019, the unsealed tube from the Apollo 17 mission, which is known as the Apollo Next Generation Sample Analysis Program, ANGSA 73001, was cracked open. Scientists discovered that the layers of lunar soil had definitely been preserved, and the sample offered insight into subjects like landslides in airless places. This study will be vital when locations and foundations for moon bases are initiated. Regarding the capsule that has been sealed for 50 years, the NASA Johnson Space Center teams are ecstatic because it might not only consist of rocks and soil, it might actually have gas. Scientists expect that the tube could contain substances known as volatiles, which evaporate at normal temperatures, such as water ice and carbon dioxide. The materials at the bottom of the tube were extremely cold at the time they were collected. Since the amount of these gases in the sample is expected to be very low, scientists are using a special device called a manifold, designed by a team at Washington University in St. Louis to extract and collect the gas. The other new exciting toy that NASA is enthusiastic to play with is called the Apollo Can Opener. It was developed at the European Space Agency, or ESA, and it has the capabilities to pierce the sample and capture the gases as soon as they're released, and right before it escapes. According to NASA, the careful process of opening and capturing has begun, and so far, everything is going according to plan. The seal on the inner sample tube seems to be intact, and the piercing process has been underway. It's referred to as the mass spectrometry. If there are gases in the sealed sample, scientists will be able to use the modern mass spectrometry technology to identify the gases. Basically, the mass spectrometry is a tool for analyzing and measuring molecules. And for more grand news, with NASA's mass spectrometry, the gas could also be divided into tiny samples for other researchers to study, which will surely enable a broader spectrum of study and results. Project leader at the ESA, Francesca McDonald, elaborated by stating, "Each gas component that is analyzed can help to tell a different part of the story about the origin and evolution of volatiles on the moon and within the early solar system." Then, the Apollo sample curator at NASA, Ryan Ziegler, was quoted saying that 10 years after it was proposed, the project is stirring up with excitement. Then, in reference to NASA's new tools, he said that NASA and the ESA finally have the unique equipment to make it possible. As previously and vaguely mentioned, the analysis of these samples is connected to NASA's Artemis missions, which will send humans to the moon for the first time in about 50 years. Artemis missions will be a collaboration with commercial and international partners to establish the first long-term presence on the moon. It has been noted that scientific discoveries on the moon could inspire new generations of explorers and have significant economic benefits. Moreover, the Artemis missions are extremely crucial as NASA and their affiliates will use the data learned on and around the moon to take the next giant leap for mankind, which will be sending the first astronauts to Mars. How excited are you about the 50-year-old moon samples and the Artemis missions? Your thoughts are truly valued, so drop a few lines in the comment section below. For more illuminating insights into the darkness of space, like this video, subscribe, ring the notification bell, and share this video.